In this video, we're going to be going over evaluating exponents. And in around 15 seconds, I'm going to show you exactly what we're going to be going over. First, we're going to talk about what we went over in our last video, which was on exponent rules. Then we're going to work on a set of easy evaluating exponent questions. And finally, we're going to finish it off with a set of hard evaluating exponent questions. If you learned from my videos, make sure to like, and if you are new to the channel, make sure to subscribe. First, we're going to quickly discuss exponent rules. If you have no idea what these rules are, then make sure that you watch my previous video on exponent rules, which I'm going to include a link to above right now. First, we have the product rule. The product rule tells us that if we have z to the third power times z to the fourth power, that means that we're going to have to add the exponents up, and this would be z to the power of 3 plus 4, which would be z to the power of 7. The quotient rule tells us that if we have the same base, we have to subtract the exponents. So if we had z squared over z to the power of 1, we would have to do z to the power of 2 minus 1, which would be z to the power of 1. The power rule tells us that if we have z to the power of 3 raised to the power of 4, then we will have to multiply the two exponents together. And this will be z to the power of 3 times 4, which will be z to the power of 12. Power of a product tells us that if we have two terms multiplying together and they're both raised to a specific power, that power applies to each term individually. So if we have x times y to the power of 4, this is the same as x to the power of 4 times y to the power of 4. A power of a fraction tells us that if we have a fraction like a over b raised to a power, the power applies to both the top term and the bottom term. So this will be a to the power of 4 divided by b to the power of 4. The zero exponent tells us that if we have a term raised to the zero power, then the result will just be 1. The negative exponent rule tells us that if we have a negative exponent like z to the power of negative 4, the way that we make the exponent positive is by flipping or finding the reciprocal. So this will be 1 over z to the power of 4. Notice it turns positive. A fractional exponent rule is when we have a fraction in the exponent, like if we have z to the power of 3 over 2. This will be the square root of z to the power of 3. Here we have two easy evaluating exponent questions. For number 1, we have 7 times z to the third power divided by z to the negative 5 power. Here we have two easy evaluating exponent questions. For number 1, we have 7 times z to the power of 3 divided by z to the power of negative 5. Whenever we have the same base dividing, all we have to do is subtract the exponents. So here we start off with 7, and we're going to have z to the power of 3 minus negative 5. Remember that the quotient rule tells us that when we have the same base dividing, we have to subtract the exponents. So this would be 7 times z to the power of 3 plus 5, which will be z to the power of 8. Number 2 asks 2w squared divided by 18w to the power of 6. This is something similar as the previous question because we're dividing the same base, so we need to subtract those exponents. For w, we're going to have w to the power of 2 minus 6. And we're going to multiply this by 2 over 18. To simplify 2 over 18, we need to recognize that 18 is 2 times 9. And w will be raised to the power of 2 minus 6, which will be negative 4. As we know, w to the power of negative 4, in order for that negative 4 to become positive, we need to move it to the bottom or find its reciprocal. So the w will be in the bottom, w to the 4th, and our 2 on top and 2 on the bottom are going to cancel. So on top we're going to have a 1, and on the bottom we will just have 9. So here the final answer is 1 over 9 times w to the power of 4. Here we have the two hard evaluating exponent questions. For number 1, we have 6 times w to the power of negative 4 times z divided by 12 times w to the power of 4 times z to the power of negative 5, all raised to the power of negative 2. At the end of the day, there's more than one way to solve these types of questions, so the path that I choose is not the one and only path, and you may find a different one that works better. The first thing that I like to do is solve the negative sign on the outside. The way that we turn that negative 2 into a positive 2 is by finding the reciprocal of the fraction. So we will have 12 times w to the power of 4 times z to the power of negative 5 over 6 times w to the power of negative 4 times z. And this will still be raised to the power of 2. Then we're going to square all of the terms. When you have more than one term raised to a power, that power applies to all of the terms inside of the parentheses. So we will have 12 squared, then w to the 4th squared will be w to the 8th, z to the power of negative 5 squared will be z to the power of negative 10 divided by 6 squared. W to the power of negative 4 is w to the power of negative 8 times z to the power of 2. Next, we need to simplify by adjusting the negative exponents. We're going to move the w to the power of negative 8 on the bottom to the top, and we're going to move the z to the power of negative 10 to the bottom. 12 squared is 144. And then we'll have times w to the power of 8 times w to the power of 8 divided by 6 squared, which is 36, times z to the power of 10 times z to the power of 2. And this will give us 144 times w to the power of 16 divided by 36 z to the power of 2. Barrier here to separate the two questions. And number 2 asks 2 times a squared times b to the 3rd power divided by 3 times a to the 4th times b to the power of negative 1, all raised to the power of 3. So similarly to number 1, that raised to the power of 3 on the outside applies to every single term on the inside. 2 to the power of 3 is going to be 8. A squared to the power of 3 is a to the power of 6. Remember, we're multiplying. Times b to the power of 9 divided by 3 to the power of 3, which is 27. A to the power of 12, b to the power of negative 3. When we have the same base dividing, we can subtract the exponents. So we're going to stick with the fraction of 8 divided by 27, and we're going to have a to the power of 6 minus 12 times b to the power of 9 minus negative 3. This will give us 8 over 27 times a to the power of 6 minus 12, which is negative 6, times b to the power of 9 minus negative 3, which will be b to the power of 12. The last thing that we need to do is bring the a to the power of negative 6 to the bottom to turn the exponent positive. And finally, we'll have 8 to the power times b to the power of 12 divided by 27 times a to the power of 6. And that is the end of our video there. If you learned something new or enjoyed the video, please make sure to like it. It really helps with the YouTube algorithm and promotes to push these videos out to more people. At the end of the day, I want to help you guys out so that you can get better grades. If you're new to the channel, make sure that you subscribe, and I'll see you in the next video.